Hello, good afternoon, good evening, everyone. So we still have around 3 more minutes before our live stream. Thanks for coming over today. My name is Teacher Chi Yew, from Tech Academy, one of the teachers for your NMOS. And I'll be going through roughly around 5 questions from our book A over here. That is our question 1 to question 15. I'll be picking out the top 5 questions that needs to be answered. Alright, I'm very these questions over here actually maybe just a little bit of sharing session, yeah, because I don't just teach your standard PSLE, your standard MO, I also teach O levels and A level mathematics as well. So I noticed that a lot of questions over here are actually related to our P&C, which is actually only properly taught in our J2 JC2 H2 mathematics syllabus. Yeah, so don't be too surprised. There'll be some notations over here. Yeah, there'll be some notations over here that we'll be teaching, but don't worry, we will simplify things. We will make things very a little bit more understandable. Yep, unfortunately, right? Yeah, so unfortunately some of the NMOS papers, they do actually come out with all these P&C P&C questions. Yeah, for those wondering what is P&C, it's called permutation and combinations. It's regards to arrangement and finding number of groups, alright, how many ways to do a certain thing. So majority of so these 5 questions over here, they are primarily focused on this. So get ready. We are going to have a little bit of fun time. It's primary, yeah. These are our primary school questions. Yep. So these are our primary school questions. But I will tell you all honestly, it's a little bit on the tough side. Alright, you are looking at around maybe 3-point questions from NMOS. Yeah, these are basically the questions that you will normally see in the 3 point section for NMOS. Yeah. What's the other chair? Which other chair you are referring to, Nicole? Yeah, so we have quite a lot of teachers over here. So we have quite a lot of teachers. In secondary, there will be quadratic equations. Yep, I mean it's very normal. Yeah, so when you are in secondary school, you are expected to know about quadratic equations, even in E-math. So all your completing a square, quadratic formula, yeah, normal factorization methods will all come into play. Yeah. So on top of that, you are supposed to know polynomials as well. Yeah, for secondary school. Yep. Okay. So let us begin. Alright. So thanks everyone for coming over. So we have around 116 students over here. Thanks for coming over and making a time for today's live stream. My name is Teacher Chi Yew from Tech Academy. Roughly 5 years experience teaching PSLE, MO, your O level and your A level mathematics. So for more details, you can just refer to me at the Tech Academy webpage. You can just look at our teachers and then you can take a look at my profile over there. So I should be over there. And those that are coming over for our mock test that is starting tomorrow, I'll be around. Alright, so further details will be sent to those who have registered for our mock test that has started tomorrow. Unfortunately, we do not accept any more registrations because we have already maxed out our capacity for the mock test that's happening tomorrow. Alright, so a little bit unfortunate. Alright, now let us begin. Alright, let us begin on the questions over here. Okay, let's take a look at question 6. Right, so we know if you guys are in our group, we actually have a little bit of a vote, and we are actually picking the top 5 questions which are the most problematic in our book A. So the first one being the top question over here is actually question 6. So without further ado, let us begin on this question. Let's take a look at this. Professor Lee needs 2 French, right, speaker and 2 Chinese speaker as translators, right? So we know that Amy, Brooks, and Kathy, alright, so in this case over here we have A, B, C, alright, can speak French, alright, where Donnie, Eason, Frank can speak Chinese, George, Hilton can speak both. Find the number of different ways for Professor Lee to pick up 4 people he needs. So in this case over here, you notice something, alright? First off, I'm going to simplify things a little bit. I'm going to call that A, B, C, D, E, F, G, and H. Alright, for sanity purposes. Alright, so I hope everyone can understand this one. So I will call it A, B, C, D, F, G, H. Now, so we know that A, B, C, alright, can speak French. Alright, and then we know that D, E, F can speak Chinese. Alright, and GH can speak both. So that's the idea. We need 2 French speakers and we need 2 Chinese speakers. Right? That's the objective over here. So how do we go about it? Well, that is where a little bit of combinatorics knowledge is required. Alright? So let's take a look at what combinatorics knowledge we require. So if we require, alright, R objects from N objects, there are, oopsie daisies, NCR, which is really equivalent to N factorial over N minus R factorial, ways to choose these R objects. Alright, why? So I shall omit the proof. Alright, I shall omit the proof. It's a little bit on the it's a little bit more on the advanced side. In fact, some of my A-level students won't be able to get the proof. But that's the whole concept over here. Alright, so if I have N objects and I would like to find out how many ways can I choose R objects from these N objects. Well, there are essentially N choose R ways, and it is in a way defined to be this formula over here. Now, so keep in mind, alright, when we have N factorial, alright, this N with a little exclamation mark over here is defined to be N multiplied by N minus 1 multiplied by N minus 2 all the way to 1. Right, all the way to 1. Okay, so this one is primary level, alright? This is primary level. Yeah, secondary level, we do not, I mean, yes, the content over here is much higher level than primary level, but it actually appeared in our NMOS papers, alright? So this one is kind of a NMOS question. Alright, so that's the whole concept over here. Now, let's begin. Now, in this case over here, we need 2 French speakers and 2 Chinese speakers. And then you notice that we actually have a total of 8 personnel, alright, A to G. So naturally, one standard way of doing this for Professor Lee is to conduct this, alright? The total number of possible ways is actually 8 choose 4 personnel. Alright, you have 8 personnel, I just want to choose 4 of them. Alright, so how many ways are there in total for this one? Well, we are going to use our definition over here. 8 factorial, 8 minus 4 factorial, multiplied by 4 factorial. So we're going to simplify this a little bit. How do we go about simplifying this? 8 minus 4 is 4. Alright, 4 factorial, 4 factorial. Now in this case over here, what I really want to talk a little bit about is the recursive property of the factorial function. So 8 factorial itself can be rewritten as 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial. Alright, now, so in this case, we are just going to rewrite that. Alright, and notice that we can actually cancel things out. And you can actually cancel 4 factorial away. Now, in this case over here, let's move on. So in this case, we have 8 times 7 times 6 times 5. Alright, 4 times 3 times 2 times 1. So we are going to simplify this a little bit more by cancelling things out. 6, 3, and 2 can pretty much cancel themselves out. And then we have 4, alright? 4 and 8 can cancel themselves out, and we get 2. So we are pretty much left with a very nice equation where we are just left with 2 times 7, which is 14. 14 times 5, 70. Alright, so there are 70 over here. Okay, now in this case over here, so that is the whole concept over here. And we have the total number of ways is pretty much 70 over here. Now, but you must think a little bit about it. Do all these 70 ways satisfy the conditions? They don't. They don't. Now, if you think about it, alright, let me move the paper a little bit higher. If we get, alright, A, B, and C, and any other 5 person, we won't satisfy the condition. Alright? This also holds if we get D, E, F, and any other 5 person, we will not satisfy the condition that is required and laid out to us. Why? Very simple. If you think about it, right, we need 2 French speakers and 2 Chinese speakers. Right? If we take A, B, and C, which can only speak French, and another person, right, that can speak Chinese, we won't be able to satisfy this condition. So, in both cases, they do not satisfy what we require. So, that's why, in total, we have to remove these 10 cases in total. It will be 70 minus 5, which is equal to 60 ways. Alright, that's essentially the idea over here. So the choice function, alright, so some of you guys have probably seen it in English, in your A math, right, your binomial theorem. Yeah, so the whole concept of this C is basically choosing. Yeah, so some of you guys have probably done A math over here. Yeah, so you guys done binomial theorem. You guys probably have done this. Yeah, so that is the whole concept behind this. All right, we are choosing. The whole concept of this C and choose R is to find out the number of ways to choose R objects from N objects. That is the whole concept of this. All right, so with that, let me move on to the next question. Alright, so this one is our NMOS paper, alright? So this one is from our NMOS book A. So for those parents who have actually collected our books, you guys will be able to find this question in the book as well. Alright, yeah, so this is one of our Math Olympiad questions, alright, for primary schools. Now, let's begin. Let's move on to the next question. Alright, so as voted by everyone in the group chat, question 2 is one of the second most difficult questions. So let's take a look at this one. Alright, there are 7 cards on the table. Alright, there are 7 cards on the table with a single digit of 0, 1, 2, 3, 4, 5, and 6 on each of them. Right? Some 3-digit even numbers can be formed by 3 cards among them. So, such as, for example, we have 320, 756. So, basically, we will find the number of all those 3-digit even numbers. Alright, we are looking for even numbers only. Now, especially, alright, something to keep in mind about, the digit 6 can be reversed and used as 9. So essentially you have a card that has a 6 on it, but you can turn it around and it becomes 9. We have to find the number of even numbers, 3-digit even numbers specifically, that can be created from these cards over here. Well, so you guys think a little bit about it. We have to actually break it out into 2 cases. You think about it, we have a 6 as it is. We can consider the 6. The card can be a 6 or a 9. So why not we break it out into 2 different possibilities? Right, because 6 itself is an even number. 9 itself is an odd number. Alright, so let's take a look at this one. So in this case over here, let's take a look at case 1. Alright, case 1 over here. We have 6 used as it is. Okay, so how do we go about this? Now, when we have a 0 over here, alright, it's very critical for us to keep in mind about this particular number 0. 0 can never be at the hundreds place. Because by having 0 at the hundreds place, your number is a 2-digit number. So, from this case 1 over here, we have to break it out into 2 sub-cases as well. So, we can have 0 at the ones place. Alright, so we have a 3-digit number and it ends off at 0. So, how many cards can be at the front? Alright, how many possibilities are there? Well, we know that by our multiplication principle, we look at these numbers over here, where 1, 2, 3, 4, 5, 6, other than 0. 0 has been used. So in this case, in the hundreds place, there are 6 ways to do it. There are 6 ways. And then in the tens place, there are 5 ways. So that's why total, we have 30 ways for this case. Now what about the next one? Alright, we can also have the case where 0 is, we can have 2, 4, or 6 at the ones place. Now, remember, what we really want is 3-digit even numbers. Right, so in this case over here, we can actually have 2, 4, 6 at the ones place. And what would that mean? Right, what would that mean? Well, I'll draw lines over here. Right, we'll draw our lines over here for our 3 digits. Now, in this case over here, what we are going to look out for is this one. Alright, there can be 3 possibilities. Right, there can be 3 possibilities for this particular slot over here. Because 2, 4, and 6 is at the ones place. There are 3 possibilities for the ones place over here. Now, what about the other 2? Well, in this case over here, let us take a look at the hundreds place. Remember, the hundreds place, we can't really have a 0 at all. But we can have other numbers, right? We have 1, 2, 3, 4, 5, 6. But we already know that 2, 4, or 6 are used. Right? 2, 4, or 6 are used. So, instead of having 6 numbers left, we only have 5 numbers left. Alright, so there are 5 ways over here. Now, in the tens place over here, right, there are also 5 ways. Why? Because, remember, our 0 can come back this time round. So in this case over here, we have 0 and 4 of any other numbers that are left over here. So there are a total of 5 ways as well for this one. So in total, there's going to be 3 times 5, which is equal to 75 ways for case 1. Right, now let's move on to the second case. Right, I'm going to move down a little bit. It's a little bit hard to write a little bit bigger because we don't have too much space. I don't have too much space on paper, so please pardon me. Alright, now let's move on to case 2. Alright, case 2. Now, the case 2 is 9. Right, when we had 6 just now. Now this time around we have a 9. Alright, but there's an additional condition. Alright, 9 is used as it is. Alright, and it's always inside. Now, how do we go about this? So, if you guys think about it, there can be 2 possibilities again. When we talk about 9 can be in the hundreds place. Or it can also be in the tens place as well. So that's why we can consider 2 cases. Right, 9 at the hundreds place. Alright, so there's already a 9 over here. Alright, we have 2 lines down here. Now, how many ways can we put these numbers over here? Well, we always look at the ones place over here first. Alright, we are left with 0, 2, and 4. Alright, 0, 2, and 4. So that's why there are only 3 ways for this one. And then, if you think about it for this one over here, this number over here, we are pretty much left with 5 ways. So we are going to multiply them together. 3 times 5 equal to 15. ways. Right, 15 ways. Now what about the next one? Alright, we have 9 at tens place. 9 at tens place. Now, remember, be very careful. Wherever we do not have a number at the hundreds place, we have to be a little bit worried. Because 0 might be at the front. And that's not what we want. So in this case, we have to break it out into sub cases again. Alright, 0 at ones place. Alright, there's pretty much 5 ways only. Alright, because you have 9 at tens place and 0 at the ones place, you're pretty much left with 5 ways over here. Alright, so in total, there's only just 5 ways here. But what about 2 and 4 at ones place? So this one is a little bit tough. So we have 9, and wait, over here. So we have 2 ways, and then we have 4 ways over here. Right, that is essentially the idea that I want to bring around about. And this is going to give us 2 times 4 equal to 8 ways. Right, so in this case, in this sub case over here, okay, we have a total of 5 plus 8 equal to 13 ways. And now we are going to look at all the cases and pretty much add all of them up. We have a 30 ways over here for this case. We have a 75 ways over here for this case. We have 15 ways for this case. And finally, we have 13 ways for this case. So pretty much the total, alright, the total is just going to be 30 plus 75 plus 13 plus 15. Idea of PNC. So this one is a little bit tough, alright, because you have to break it up into a lot of cases, and on top of that, we also have to consider sub cases as well. So a little bit more complex, right? But that is how question 2 is constructed. Alright, I'll try to write a little bit bigger, but it's going to be there's going to be lesser space available. Alright, so I hope everyone can bear with it for a little bit. Yeah, okay, so that's pretty much about it for question 2. Now let us move on to the next question. Right, the third most voted question in this case over here is another combinatorics question. So let's take a look at this one. So some 3-digit even numbers contain 3 different digits from 0, 1, 2, 3, 4, 5, and 6. Alright, find the amount of all those 3-digit even numbers. Now you guys think about it, this is question 1. And if you look at it closely, it's very similar to question 2, which is a question that I went through just now. Right, but this one is much easier. And I'll probably write a little bit bigger over here. So let's take a look. Remember, when we have a 0 over here, right, we have to consider 2 cases. Alright, we definitely need to consider the case where 0 is at the ones place and all the other even numbers at the ones place. So what's the first case, right? Let's do the simpler case over here. Alright, case 1. Alright, case 1. So 0 at ones place. Alright, 0 at ones place. Now in this case, we are going to look at 3 numbers again. And 0 is at the ones place. So how do we go about it? We know 0 is at the ones place already. So how many ways are there to fill up the hundreds place? There are 6 ways. And what about the tens place? Well, we used up 1 digit, so we are left with 5 ways. So in total, there's going to just be 6 times 5 equal to 30 ways for this case. And what about case 2? Alright, about case 2. we have 2, 4, 6 at ones place. Alright, so how do we go about this? We are going to pretty much do our underlining again. And this one, there's going to be 3 ways. Because there are 2, 4, and 6. That's the main idea over here. Then what about the hundreds place? Well, remember, the hundreds place cannot accept 0. Otherwise, your 3-digit number is going to end up as a 2-digit number. Alright, so we have to avoid that. So if we look at it carefully, we have 1, 2, 3, 4, 5, and 6. But we have to minus away one number because one number is used. So that's why there are 5 ways over here. Okay, and afterwards, this one over here, we are pretty much there with 5 ways as well. Alright, so this one isn't A math, but if you guys, this one isn't A math again. This one itself is actually your NMOS, preparation course. Alright, it's part of our NMOS preparation course series. Basically, it's for primary school math Olympiad. Yeah. So you have seen some notations. You guys have done binomial theorem and things like that. You should have seen some notations that are similar. Alright, but this is not A math, alright? So do not worry too much about it. Alright, so in total, we are going to have 3 times 5 times 5 equal to 75 ways for this case. Alright, so in total, there's going to be 30 plus 75, which is equal to 105 ways. 156 there is a little bit of typo. Alright, so don't really mind it. Alright, so let's just ignore this. Let's just ignore this particular number over here. Alright, so with this, that is pretty much about it for question 1. Right, that is the whole concept for question 1 over here. Alright, I hope it isn't too hard. Okay, let us move on to the next question for the day. Alright, the 4th most voted question. Alright, which is question 7. Alright, question 7 is actually something that is very manageable by a lot of students. Alright, all we have to do is to look out for a particular pattern. So let's take a look at this question over here. So find the number of 9s in all the natural numbers, alright, that do not exceed 1000. Right? For example, 929, it contains 2 9s. So how do we go about dealing with this question over here? Right? The idea over here is to actually write out some numbers first to get a feel to see if you can identify a pattern or not. So we are going to look at the ones places first, alright? The ones digit. Right? The ones digits. Well, what are the ones digits? Well, we pretty much have 1, 2, 3, 4, 5, 6, 7, 8, 9. How many 9s are there over here? Right, so in this case, there is only just 1 9. Alright, so I'm going to literally write 1 and 1 9 over here. Right, 1 9. Now, we are going to move on a little bit, alright? So this one isn't anything special. But let's move on a little bit. We are going to talk a little bit about this one. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Alright? There's also just 1 9. Alright, and you guys can see a pattern. Right. So from 20 to 29, alright, to 20, from 20 to 29, there's also going to be 1 9. Alright, there's also going to be 1 9. And 30 to 39, there's also going to be 1 9. Alright, now, what's next? What's next? The next thing over here is that you can see a particular pattern that's going on. I do not have to write so much over here now. Now in this case over here, I can move on all the way down to 80 to 89. Each of them is going to have 1 9 each. That is the whole idea behind this question. But what about 90? 90 to 99. So in this case, 90 or 99, maybe it benefits if we list it up. Alright, so we're going to have 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. And if you actually count all these numbers over here, we have 19, 29, 39, 49, 59, 69, 79, 89, 99, 10 nines, 11 nines, alright? So 11 nines. So how many nines do we have in total so far from 1 to 99? From 1 to 99. You guys count, alright? So we have 1 9 from 1 to 9. Another 9 from 10 to 19. 20 to 29, there's one more 9. You guys can see a pattern that's brewing over here, right? So from 10, there's 1 9. 20, there's another 9. 30, there's another 9. 40, there's another 9. So all the way down to 80. So 10 to 80, we are going to have a total of 8 nines over here. Alright? And then plus 1, this one is going to give us a total of 9 nines. Right? 9 nines over here. Now, the next one over here, we are going to ask ourselves 1 to 99. How many nines are there in total? We actually calculated it, right? We actually have 9 plus 11 equal to 20 nines. So that's the concept that I want to bring around about. Right? We are counting the number of nines from 1 to 99. And we figure out that there are actually 99 nines so far. Okay, let's move on a little bit more, right? Let's move on a little bit more. We're going to notice a little bit of pattern over here. What about 100 to 199? How many nines should we expect to see from here? Well, the pattern itself will actually repeat. Alright? Because if you think about it, 100 is really just 1 at the front. Right? But we are still essentially counting the number of the number of nines from 1 to 99 as well. So you can actually see, yeah, exactly, right? So you guys are going to see 20 nines as well for this one. And you guys can see a pattern going on, right? 200 to 299. Another 20 nines. And we want to calculate all the way down to 800 to 899. I'm purposely avoiding the 900s. Alright, and this is going to be 29s again. Right, so far in total over here, you guys can already count that we actually already have 189s so far. 189s so far. Right, from 1 all the way to 899. Now what's next? The next important step to keep in mind about is our 900 to 1000. Alright, I mean we can exclude 1000 because 1000 doesn't have any nines at all. So we're going to look at 900 to 999. Alright, so how do we go about this? If you look carefully, in every single digit of starting from 900, there's at least one 9. So from 900 to 999, there are a total of 100 digits, alright? 100 numbers over here, alright? So I'll shift it there a little bit. There's going to be 100 numbers over here. Alright? So you are expecting to see another additional 100 9s over here. That's the idea, exactly. So in this case over here, we are going to have 100 plus 20, which is 129. And do we pretty much get the final answer? Yes, we pretty much end up with the final answer already. So in this case over here, you guys notice I have 189s from 1 to 899, and I have 129s from 900 to 999. So pretty much the final answer is just going to be total 180 plus 120, which is equal to 309. That is the idea for this question. So this one is more about pattern recognition rather than permutation combination. Alright, PNC itself is a hard topic, but I would expect students to be able to do this pattern recognition kind of idea over here. We are actually looking out for a particular number in a sequence of numbers. Right? So this one is mastering these kind of questions would be extremely advantageous if you are going to do the Math Olympiad and the upcoming NMOS. Alright, so I hope all's good for everyone. Alright, let us move on to the last question for the day. Alright, the last question that was voted, the fifth question, the fifth most popular question is actually question number 8. Alright, another permutation and combination question. So I noticed that maybe it's not all 5 PNC questions, maybe 4 PNC questions and one pattern kind of like question over here in this case. So let's take a look at this one. Alright, find the amount of all the 4-digit numbers, alright, all the 4-digit numbers that are formed only by digits 2, 0, and 3. And another very important condition is each of those appears at least once. Okay, so in this case over here, if you think about it carefully, the key word in this case is actually appears at least once. Alright, we can break it up into three straightforward cases with that, because we definitely need to have a 2, we definitely need to have a 0, and we definitely need to have a 3. So what are the possibilities for the fourth number? Well, the fourth number can be either 2, 0, or 3. Alright, so there are actually 3 possibilities, alright, 3 cases to consider. Alright, so there are 3 cases over here. So the first case, alright, is really 2, 0, 3, and our wild card over here, which is 2. Alright, the second case is pretty much 2, 0, 3, 3. Right? And then the last case, 2, 0, 3, 0. Right? So there are 3 possibilities for this question. Right? That's essentially the idea behind this. Now, how do we go about doing this question? Well, we have to consider case by case. How do we go about it? Well, we are going to look at case 1, for example. So in this case, let's take a look at case 1. Alright, case 1. We are going to use 2, 0, 3, and 2 to construct our numbers. Right, we are looking at 4-digit numbers over here. So how many 4-digit numbers are there? Well, the most standard way of doing it is to actually put the 4 slots over here. Now, in this case over here, it's definitely going to greatly benefit us if we are to arrange the 0 and the 3s. And then afterwards, you can simply just slot in the 2s. Well, you have a 0 over there, and 0 is always a problem. 0 can't be at the hundreds place. So where are the places that 0 can be? Alright, so the 0, the number 0, can be at hundreds, tens, or ones place. Alright, so there are 3 possibilities over here. 3 ways. And what about the 3? Right, the 3 can actually have 3 possibilities as well. Alright, after 0 has taken one of the places over there. Alright, there is going to be 3 possibilities. So total number of ways is really just going to be 3 times 3, which is equal to 9 ways for our first case. Alright, the number of ways to form a 4-digit number using 2, 0, 3, and 2. Alright, now let's move on to the next one. Next case over here. Alright, I'm going to move it down a little bit. How about case 2? Alright, we have 2, 0, 3, 3. Right, 4 numbers again. Alright, we have our 4 numbers again. Remember, our 0 can actually be at the hundreds, tens, or ones place again. Alright, which is 3 ways over here. Now this time round, we're going to arrange our 3s. We are going to arrange our 2. Right, because 2 is easier to arrange. Now, our 2, this time round, can actually take up 3 possibilities. So, how many ways are there over here as well in this case? Well, we can really see that there's just going to be another 3 ways over here. Alright, so I'm going to move it down a little bit. Alright, there's just going to be another 3 times 3, which is equal to 9 ways. Now, what about the last case? Alright, we are pretty much there. Alright, we already considered 2 cases so far. We just need to put a little bit more effort and then we'll be able to get the final answer out. Now, the last case over here is our case 3. Alright, we are going to have 2, 0, 0, 3. Now we have to be a little bit careful over here. We have to be a little bit careful over here. Why? Because this time round, we actually have 2 zeros. We actually have 2 zeros. Where can the 2 zeros be at? Let's list it out, right? That is going to give us an idea of where the zeros are going to be at. Alright, so the zeros definitely cannot be at the thousands place. Well, but we know that the 2 zeros over here, they definitely have to occupy the hundreds. Right, they definitely have to occupy the hundreds. Alright, my apologies. Definitely have to occupy the hundreds, the tens, and the ones place. So we are going to label them out a little bit. Alright, we are going to label them out a little bit. How do we label them out? So we are going to look at the cases. Alright, so it can be a 0 over here. It can be something like this. This is one possibility. What about the other zeros? Alright, what about the other possibilities? It can also be like this. Right? Or finally, it can also be like this. So there are 3 ways to arrange the zeros. Right? There are 3 ways to arrange the zeros. Now what about the 2 and the 3? Well, we have a 2 and a 3. Now think about it. All we have to do is to actually slot in the 2 and 3. Right? In a very standard fashion. So if you look at it a little bit carefully, in each of the cases we have a 1, we have a 2, 3, or 3, 2. Right? A 2, 3, or 3, 2. We have a 2, 3, or a 3, 2. Alright, so this gives us an idea that in each case, there are 2 ways. Alright, in each possibility, there are 2 ways. Right? To arrange the 2 and 3. Right, that's the idea. So, how many ways are there in total? Well, you can really count it out actually. So, you actually have 2030, 3020, 2003, 3002, 2300, and 3200. And voila, you guys are going to get pretty much 2 times 3 equal to 6 ways. That's the idea that I want to bring everyone about. So now we have all 3 cases already, right? We actually have all 3 of our cases over here already. So we are just going to label them down again. Alright, so there's going to be 9 ways. Right, there's going to be 9 ways here also. And this time around, this one, there's going to be 6 ways here also. Right? So what does this really mean? Well, we can really add up all the cases together in order to obtain our final answer. Right? So what's our final answer? Well, we can pretty much take 9 plus 6, and we are pretty much going to get a final answer of 24 ways. Alright, so this one is going to be our final answer for question 8 of our NMOS book 8, 24 ways. Alright, so with that, that is actually pretty much it for our live stream over here. So before everyone leaves, I would just like to remind everyone about our upcoming NMOS mock paper and parent seminar, which you can actually register on our bio over there. And on top of that, the fee is actually $9. On top of doing that, if you are going to, if you guys register for our parent seminar and NMOS mock paper, we will also throw in our complimentary book B, alright, which also consists of 50 pretty difficult questions in order to prepare your child better for the upcoming NMOS examination. Right, so that's essentially the thing that I would like to talk a little bit about. The link, the sign up link and registration link is our bio. It's only $9 and you guys are getting pretty much 50 questions for our book B that will make sure that your child does much better in the upcoming NMOS examination. So with that, that is pretty much about it from me. Right, thanks everyone for their time today. And we are probably going to see each other next week. And next week, gentle reminder, the next 15 questions will be up for voting in our NMOS group. So make sure to vote for the questions that you are not sure how to do or how to tackle. And we will be doing a live stream in order to cover these questions. Alright, with that, thank you very much everyone. And I will see everyone next week at Friday, 8 to 9 p.m. as usual. Alright, thank you very much everyone. And I will see you guys around. Bye bye.